and go on to week 9. Okay, so let's talk about what we were doing. I'll refresh your memories. We have started working on complex select statements. And by complex, of course, you've learned a few inbuilt functions that are not very complex, but you have to know how to use them. But the emphasis more is also on group by and having. So something that was absolutely new, right? So group by will take your data and group it by the field that you have mentioned. So it's kind of forming groups, putting them together. That's what group by does. And having puts a condition on the groups. So as keep in mind, where puts conditions on your selects. So it is saying select from, and that's the combination. What I want to do, what do I want to select? So where is to from, as having is to group by. Okay, so having puts conditions on group by. So we did a small exam. I mean, I think I did, or didn't I? No, I haven't yet. Okay, so we'll do that. So we were on the last one. This last one is a little complicated. So we left it at this and we'll now discuss it. So it says which girl or girls, it could be more than one, sold cookies greater than 0. So sales must be greater than zeros. So you can say sales has to be greater than zeros on maximum number of days. So every girl is selling cookies. We are saying which one sold it on maximum number of days. That's what we are trying to do. So one of the solution which is not foolproof. This is not foolproof. Why? Because I'll show you why. Right, so this one is not foolproof because I'm assuming that there is only one girl with the maximum number of days. That's why I say show me limit 1. Right, so what do? I say, okay, get me the first name, count the number of sale dates from the table where sales are greater than 0, group by first name, order them and show me the first record. So the assumption here is that only one girl sells cookies on maximum number of days, which is a wrong assumption. It isn't right? You'll say, oh, can I do this without the limit? Can I just show them order by? Yeah, but then it's not the answer I'm looking for. I'm only looking for those girls. But if I do it this way, let's run it. So you have the whole table. And you'll say, oh, I'm looking at the table now. I'm looking at the results and I see there are 2 girls, Nicole and Brittany. So let me say limit 2. But that's not the right way, right? You're trying to find the answer from the answer. So it's not foolproof. You'll say, I'm okay to look at the whole table. But here it's okay. There are only 4 records with 2 people. What if there are trillions of records and the first 100 records have the same value? Like you can't keep doing this. And you shouldn't. Logically, you shouldn't. So this solution, I'll keep it here, but it's not foolproof and it's not a good solution at all, right? So I'm going to comment that out because we know that it works. We know that, oh, there are 2 girls with 7 and 7. And so that's fine. If you're seeing a 7666, maybe you didn't change Brittany's sale date. I changed it in one of my records. If you remember last week, I went up, I said, let me show you that what happens if there's, so I think I changed this one. Anything that had a 0 somewhere with Brittany, I changed it to a value. So therefore, I have a 7766. You may have a 7666. You could. So I changed it to show you what if there are 2 girls? What do you do then? So now let's write a foolproof way. So what is the logic? If I can find out the maximum value, which I can, I mean, I know how to do that. The first value will be maximum. And then compare all the other records with this maximum value and spit out the ones in which this maximum value matches, I'm okay. Right, so I'll do it in 2 steps. One, I'll find out the maximum value, which will this will do for me. The thing I've written, the solution I've written will do for me. So I'll find out what's the maximum value, and then what will I do? I will then go through the records, do the same math, and then only spit out the records whose count matches this maximum value. And then I can never go wrong. Whether they're 1 girls, 2 girls, 3, 400, really doesn't matter. Anything that matches the maximum value will be spit out. Okay, so that will be the correct way of doing it. And that's what we should always do. So let me try doing it now. So now foolproof and of course the correct, not only foolproof, I should say the correct one. The correctness is more important because here you are assuming that there is 1 girl. That's why I said, show me the first value, limit 1. That's why I kind of did that, but it's not right. Anyway, it's not right. Right? If otherwise I said, show me everything, then it's okay. You're showing me everything. So now let's do it foolproof and the correct way. So what am I going to do? First, I'm going to find out the maximum value and save it in a variable. Till date, you haven't done any variables. We've always worked with field names of tables. But It's just a language. It's just something you can use variables if you want. So the assignment statement in MySQL is done through set. Okay, so you are saying set this variable. Variable names in MySQL start with an @ so that they're differentiated from field names. Otherwise, how will the compiler or the runtime unit say, oh, is it a field name you're talking about or is it a variable name? So variable names start with @ always. Then the other rules are the same. You can use letters, digits, special character underscore, or the convention, whatever you like. So I'm sticking with my convention of underscore. So I'm going to define a variable called max value, and I'm going to give it a value. So the set is the assignment. The name of the variable is max value. You could have called it anything you like. Max value is not a bad name at all. Please don't call it ABC. And now in this, I'm going to put the count, the maximum count. So what am I going to do? Since it's a variable, it can only take a value, right? It can only take one value. So I select the count. I group by first names. And I do the same thing. My logic remains the same. I go limit 1. So it will pick up the first value and it will assign it to the max value variable. The logic still remains the same. What is it saying? It is saying select the count of sale dates from the table where sales are greater than 0. We are not counting if sales is equal to 0. That's not a sale date, right? Group by first name, order by 2 descending, and then pick up the first record. Limit 1 means pick up the first record. It only has a single value. I assign it to the variable. Please keep in mind 2 means the second. Oh, sorry, it won't be 2 now. Order by 1. There is only one field. Or you can copy the whole thing if you like here. You can do that too. So order by, when you see a number here, it's corresponding to the field, to your field in your select clause. 1 means the first field, 2 means the second field, 3 means the third field, and so on. Right? So what will it do? It will do the same math that it was doing. It will count for every girl. It will count the number of days. It will put it in descending order. So 7766. Kind of thing. This is the table that I'll get without the first name, right? Without the first name. Why? Because a variable can only say one value. So I'm doing this. So I'll get this result, 7766. Limit 1 will pick up the 7 and assign it to the variable max value. I have the value now. Now all I have to do is compare and spit out. Right? So the logic remains the same. Find the maximum and then spit out. Now let's spit out. So what do? I again kind of. So once I have the value, I'm going to do this. Okay, now get the count from the table where this, and of course this will change. Now what should you do? What is the condition? The condition is I only pick up those records in which the count is equal to the maximum value. Right? So I have to put a condition now. So I'm saying select my name, select the count like I was doing before. And of course, it would be nice to have a name here. What would you like to call it? Maximum sale days? Remember, anytime the heading has blanks, you have to put it in quotes. If it is a single word or has underscore or whatever, underscore, remember, is still a single word, then you don't have to put it in quotes. But the main use of giving it pretty headings is that they're prettier, right? They're better to read. So here also, if you like, nothing stops you. You can do it here also. For consistency, that all names are like English-like, right? So I'm going to do the same thing now, but I have to be very careful. Now, which records do I pick up? So I'm saying, okay, get me the girl name, get me the count from my table. Only select those records where sales are greater than 0. Group them by first name. And now the condition, having. So having is how you set a condition on your group by. Only pick up those records where this count is equal to the max value. And your job is done. I've put a condition. So I first find what is the maximum value. Then I pick up only those records from my resultant table that match the maximum value. So I must now only see 2 records, the ones that match the 7. If you want to order it, it's different, but I mean, otherwise you don't need to order it. right? But if you want to say, oh, I'll order it by first name, I mean, that's really, it's up to you. It depends upon the question being asked. You can order it if you like. That way it's easy to see. Remember, human beings, for us, seeing something sorted is always easier to read. The maximum value will be the same. So I've ordered it by first name because then I see an ordered list. Okay, now try that. So I'm going to comment this one out, but this is how you kind of think about it. And I've used the same logic. My logic still remains the same. I'm doing what I was doing here to find the maximum value. And then I kind of do the same thing, but I put a condition on my group. So having is like a where for group. Keep that in mind. You're setting a condition. So you're saying only pick up those records in which the sale count is same as, count of sale is same as the max value. Try it. Right? So I've already run the script once, so only this will also do. Of course, the first one doesn't have any output at all. It's just a set statement. But look at my answers now. There. I only get those girls in which it is 7. Try to put more. Add another girl. Ashley is not here. Change the Ashley from 0 to something else. She'll also become 7. Or remove it from Brittany or Nicole. Only one record will come up. It will work. It is foolproof now. Because I'm not relying on, are there 1 girls or 2 or 3? I have no clue. I am relying on the correct fact that pick up those records where this count value is equal to that max value. So I'll never go wrong. Right? So that's how you will answer it. But here is how you use having. So having is checking a condition on the group. So you attach it with group. And if you have to do an order by, please remember to always put it at the end. I don't have a having here, but I have it here, see? So having is to group as where is to from. From and where together, group and having together, and then comes order by or whatever you want. There's another one, limit. That's the only one. So the sequence is kind of important. So select from, where, group, having, order by, limit. Here I don't want to do a limit because, I mean, I have to show all the records where they're matching the max value. So you've been introduced to how you can use an assignment statement, which of course you will go ahead and do more of it when you go to your next semester, where you will do the advanced programming. That is where you will start to kind of write your own stored procedures and triggers and so on. I've never taught that course. It always kind of falls in the winter, and I don't teach in the winter. So I'm not sure, but definitely it's programming. I know that, right? So that's where you will learn more of this. But it's not so tough to learn. It's just an assignment statement. It's not a big deal at all. Okay? Okay, so that takes care of cookie sales. So this was the only one that was left. But since you've done having for the first time, I would like to do 2 more examples with having. A little more complex, but I would like to do 2 more examples so that you know how to use it, right? And then I'll kind of switch on to normalization. Okay, so once I'm done at the end of the class, I'll place this solution back on Blackboard. So I've removed or I've commented out the one that I said will work, kind of will work. But of course, it's not correct. Okay, now open up Grade Center. Open up the next that you had from last week. It was in the week 8 zip. We hadn't even started working on it. So if you don't have it, pick it up from Blackboard. Okay, so what is this doing? It is maintaining information about, okay, there is a syntax error. Please see that you take care of it at line number 23. The not and the unsigned were together, so it was giving an error. Right? Okay, so what does this do? If you look at the table, you see that there is a first name and a last name and a student number of a student. It's a grade center, like grade books that we maintain, right? And of course, you see it from your side, you see your marks. The course, the name of the course, and then the grade you have in it. So it's kind of saying this is your grade center or your grade book where it is showing the student name into parts, which you can always concatenate. A student number, which is unique, but what am I missing? I don't have a primary key. So I didn't put it here so that I could do the alter statement for you so that you know how to do it, right? Again, reiterating, you can never forget your alters. You cannot forget anything you've learned till date. It's building up. And then it has a course name like intro to whatever, object oriented, or maybe just the number, which is better. COMP1030, COMP1008, and so on. And that's why I think I have a character 8 there, COMP and the number, right? Of course, you could go more. And then comes the grade, which is a tiny int, because the grade is always out of 100%. So tiny int is good enough for me. It is unsigned because grades can never be negative. And then not null, I need a value there, and the default is 0. Okay, so that's my table. Definitely this table does not have a primary key and is not a good table. So what do? I change it. So as I said, you could have put it right here, but I just thought I'll again reiterate it. So after you create a table, make a habit of always describing it. Of course, for your own. If I don't ask it, then I don't need it. But describe will always tell me, was the table created as I wanted it? In this sense, are all the characteristics right? So if you kind of just run this, this is what describe does. See, so it tells you the field names, the field types, whether it can be null or not null, whether it's a key, whether it's a primary key. You will also learn about foreign keys in a while. Ignore the default column. I have no clue. I don't read, it doesn't read right. So I'm kind of leaving it. And extra means if you have given, like you've said something about extra about it, right? That's when it comes. Auto increment, for example, is an extra example. That's what will come in the extra field. Okay, so I would ignore the default where it says null, because if the field is not null, how can the default be null? So I don't know how to read this field. It's very confusing, but I can do much about it. That's how it puts it. Now, after that, what I've done is I've put some records into the table. Now, we all know that student numbers are unique, but notice something. Since the same student can have more than one courses, logical, she or he will have more than one records in the table. Now, here is one design issue to start with, absolutely to start with. One, redundant data, right? Why redundant? Because the information that Flynn has, the student number, whatever, 1, 2, 3, 4, 5, is occurring as many times in the table as that particular student is taking courses. So if it needs to be changed, which will never change, of course, but if anything needs to be changed for a student, then you have to go through, suppose the name of the student has changed for whatever reason, then you'll have to search for all the records in which that student ID occurs, change the name of the person, and there it is. You'll say, how long does it take? I'll put an update statement and do it. Yeah, you will, but notice something. Let me tell you, when you're working with databases and table, you are not the only person who's trying to extract data from the tables. While you are maybe updating a particular row, somebody else may be selecting data from that table. Right? So there are 10 records. Only the first one is updated yet. The second to 9th, 10th are not. Another person selects data for this particular student, Flynn, and one says, oh, her ID is this, and the other one says her ID or his ID is this. So there is inconsistency of data. And therefore, normalization is a big design issue in databases to avoid redundancy or duplication of data. Because if the data is redundant, you will have anomalies or problems in insertion, updation, deletion, and so on. And that has to be avoided. There are solutions. Before you work on a table, you can always lock the table. You are saying, while I'm updating my data, it is not accessible to anybody. You can do that. You can lock it, right? And then you're safe. But generally speaking, you can also lock rows if you like. So if you're working with a row and you're updating a row, that row can be locked. And this behavior is what comes from the storage engines that I was mentioning, like MyISAM, InnoDB. There are certain storage engines in MySQL, and by default, 5.7 onwards, it's InnoDB. But on my machine, it was MyISAM when I checked. So I have no clue why, because I have the latest version of MySQL. So I'll show you how to kind of ensure that you're using the right environment. Okay, but again, MyISAM rows locks tables when it works with tables, but InnoDB only locks rows, which can of course be changed, right? But data duplication, data redundancy is a big no-no in the database world. For the simple reason, anything that's duplicate can lead to data integrity. It harms it, right? So the data may not be the same in all records while things are being done. So at any given point of time, 2 records may have the name of Flynn changed to Anju, and the rest of the 4 records, the name has still to be changed. So that is a part of inconsistency. So to avoid that, design principles are followed, and we will learn how to do that in class today. So this is not a good table, let me tell you, right? But it was serving the purpose for me today because I want to show you group by and having. That's why. So that means student number cannot act as a primary key because student number is being repeated. It's not unique. It repeats with every person who has repeated data. And you can see data is being repeated, right? Definitely, I can see for two persons. I can see Flynn and I can see Fletcher. And I can see Fletcher again. And I can see Baljeet again. So I can't use student number because student number is repeated. So the only option that remains with me is this. What do I do? Is this table in the first normal form? Nope, because it doesn't have a primary key. Right? So you can put that note for yourself, though there is another condition about first normal form which we'll learn today. But you can give your answer here. You can say no, since there is no primary key. We'll learn more. Right? Now comes. So let's add one. How do I add it? I alter my table. I add a new field. I can't make student number my primary key. I cannot. So I can't say, oh, add primary key student number. That cannot happen because of my data, right? Because of how I have created the table. So I say, okay, add a new field, call it ID, make it an int, auto increment. It should be not null, and it's the primary key, and it will be placed as the first record. Right? So remember, first we'll place it in the first position. Though, like, you don't have to, but it's just a norm that primary keys always occur in the first position because they're easy to read them. So now my table at least has a primary key. There is another condition of first normal form. Once we know it, we'll come back and see if this table is in the first normal form or not completely. Okay, now again, I just do a describe and a select. So at the end, I should have my data, which it is, there it is. And I should have my result of, and it should say that it is a primary key. So it's, I'm fine that yes, now I have a primary key. It is an auto increment field. It is called ID, and the rest of the fields as I had wanted them. And here is my data. So you will see that last names are missing for Baljeet just because I didn't put them. It was an empty string, right? It was an empty string. Okay. Now what? Now let's look at the two questions I've given you. And what I've done to make it easy for you to understand, I've also, and I will put this up on Blackboard, I've also created an Excel worksheet for the questions, so that's easy to follow. Okay, so now let's look at what the question is first and then come back here. It says create the list of potential tutors, so people who can give tutoring to other students. The requirement is that that student must have 80% marks in at least 2 courses. Only then can you become a tutor, right? So what will I check? I'll say, okay, let me group my students according to their name, more than name, student number, because student numbers are unique in this sense for each student. So I'll group them. Then I'll see how many courses have you done. Maybe a student has only done 1 course, so that's out. That person cannot be a tutor. A person can only be a tutor if the student has received 80 or higher in at least 2 classes. So if the student is only taking 1 class, not eligible for tutoring anyway. If the person is taking more than 1 classes, that is 2 or more, then he or she is eligible to be a tutor if they have at least 80% in 2 courses, at least, so 2 or more. So logically, what will I do? This is my logic. This is what I'll do. I only want to first select records where the marks are greater than 80. I mean, otherwise, the rest can just are not even important, right? So I'll select the records that are greater than or equal to 80. Then I'll group them according to student number. Then I'll pick up only those groups in which at least there are 2 subjects, because the one with 1 subject, again, out. Even if the student has 90, because I said at least in 2, so they are out. So what am I left with? I'm left with only those groups now in which they have 80% or higher in at least 2 subjects. That's the logic. So kind of think of it. I have to do selection where grade is greater than 80. I have to do group by because I have to group students by their student number. And then on group by, I have to do a having such that they have 80% or higher in 2 or more subjects, right? So that's what I need. So I need group, I need where, I need having, all 3. So if Excel makes a little more sense, what I've done here is I've kind of shown it to you like I'm saying it. How would I do it? So the first step I would do is I'll pick up where grade is greater than or equal to 80. So from this table that I've given you, Excel is just a worksheet. It looks like almost a table, right? It's easy to work with. Then what I've done is I've only picked up those records where the grade is greater than 80, because otherwise they're not even important. Then I group them by student number. And in that group by student number, I only pick up those records now where at least they have more than one course, right? And of that more than one course, the ordering is not so important, but what is important is the marks should be greater than 80, which I've already done first. So pick up those records where it is greater than or equal to 80, then group them, then only pick up where the count is greater than 1, which is 2 or more, and then just order by last name and first name. So the ordering is just ordering them, nothing else. Right? This is what I need to follow. This is my procedure. And the solution comes here, but of course we'll try to write it ourselves now, right? The solution is here, but we'll try to write it ourselves now. Okay, so now go with me. So we've already said what we want to do. So it says create the list of potential by providing the first name and the last name. Okay, so select first name and last name. You can always concatenate it. It didn't tell me to, but if it says show me the name, I can always say concat first name, last name, okay? And then give it a good name. Okay, so that's step number 1. So step number 1 says show me the first name and the last name. Of course, from which table? From the table called grade center. Oops, yeah, spelling is right, grade center. Now, only those records need to be picked up where the mark is, what is the mark? Grade? I think it's called grade. Yeah, where the grade is greater than, at least means greater than equal to 80. At least means greater than equal. So here I only have records that are greater than 80. Why need I look at the other ones? Doesn't make sense, right? Now I want to group them. Now, how do you want to group them? Since student numbers are unique in this sense, not unique in your table, but they're unique for each student, don't group them by name or anything. Group them by student number. I think it was called stu number. Oh, there it is, student number, right there. Not a good name at all. I should have gone with total number, but anyway, group them. Okay. So the 80 and above is already taken care of. Then I group them because I want to see how many subjects taken by each student. And of these, I only pick up those groups that have count of what? Of their course. Was it course? Yes. Is greater than or equal to 2 you can write, or you can say greater than 1, whatever makes more sense to you. Since the question kind of says at least 2, I'll kind of write it like at least 2. But you can say greater than 1. Make sense? That's exactly what I said I would do in the Excel worksheet. So pick the records with greater than equal to 80, group them by student number, count them for each student, and I used courses. You could use anything, but you could even just say count the name, count the number. The course just makes more sense because that's what I'm counting, but you could count on anything because now you have them in a group. So you can even count by first name, by his last name, by student number, whatever you like. So I counted them by course because it just seems logical. And then I only pick up those records in which the count is greater than or equal to 2. And it says, please, I thought I saw order by, yeah, listed alphabetically by last name. Now order them. And it says order by last name. Doesn't say descending or ascending. Doesn't say ascending or descending. So you can leave it like this, or you can put descending in it. Doesn't matter. There's the solution. What isn't it like? Order by spelling is wrong. There it is. Done. Right, so here is a complete example. Again, the limit is missing, but we don't need it here. But that's what it is. Select from where, group by, having, and then order by, and then limit. That should work. Right, so the result should be, if you go back to the Excel worksheet, at the end of the day, the result should be 3 students. I have 3 students here. And it's just following the logic. See, when I say greater than 80, I get these records. Then I group them by. When I group them by student number, I've just shown the grouping by putting them together, right? Of this group by, this will be ignored. Why? Because the student only has 1 course. This student has 2, this student has 2, this student has 2. There could be 3 also, 4 also, doesn't matter. So you only pick up anything that is 2 or more. And then If they have 2 or more, definitely they are greater than 80 because that was your first filtering. Only pick up greater than 80. So that's filter has already taken place. So anywhere you see 2 or more, pick them up and they become your result. Of that, I only want the first name and the last name, and then I order them by last name. Right? So if I run this script, I should have those 3 names. There it is. There's the result. So remember, why is Baljeet coming first? Last name blank. So blank has the smallest ASCII value. So blank comes first before any of the other letters. So therefore it comes first. It has 20. You must be familiar with it in your HTML also. Percentage 20, right? That's its ASCII value. And it is less than any of these A to Zs that start from capital A, 67 or something, I think, 61 or something, I forget now. But anyway, it is the smallest of the letters. So it comes first. Done. That's how you use group by and having. Right? Now let's try the other one. So there's another one. I'll put this Excel worksheet for you on Blackboard, just if it helps. Okay, what does it say now? It says find the average mark of each student. So grouping comes again, because average mark is what? Add up all the marks and divide by the count. So I don't know how many each student is taking. I have no idea. Same what you did in Java with your, this is the other section, with your patient. How many weights? Add them up, divide by the total number of weights. Same concept. So how do you find the average? Average will, irrespective of whether your marks are integers, please remember average can always be a real number, because after addition and division, your answer can be real. So I need to calculate average. So as soon as I say average, that means you want to add the marks of each student and then divide by the count of how many records that particular student has. That will give you the average. But it also says cast it with 1 rounded to 1 decimal place and label the average grade column as average mark. Right now, this average mark is not very readable, but it is matching the format of a field name. So that can be done too. So I'll keep what it is. So it says average mark of each student. Okay, if you again go back to the worksheet, think what we need to do. So what do I need to do to find the average? Group them by student. And then once you've grouped them, you have to do a little bit of calculation. And the calculation is what? Sum divided by count will give you the average. And then just show it. But after that, you give it a name, which is just as, then you cast it with 1 place after decimal, which is a cast. But the calculation just says group up, divide, and then show the result. Okay. So the first thing is I group by student number. So as soon as I group by, I get this table where I'm grouping, right? So I've grouped it. After I group by, I do an average. So you'll say, do I need to do sum by count? No, there is an inbuilt function average available. I even don't have to do that math. Remember, there is an AVG average function available. And then the casting is just casting it with 1 decimal place and then showing it as an average mark, like a proper name, and your job is done. Right? So let's try it. Okay, so what do I need? The name doesn't say anything. So that means I need the name for sure. It says average mark of each student. So unless you show the name, if you want to use concat, here, let's do something different so that you can see it again. Let's concat the first name and the last name by putting a blank in between. I mean, you'll say, why are you showing the name? I mean, otherwise, how does the average mark make the sense at all? Right? So we'll concat them. And of course, when you concat it, you always have, otherwise it will look very untidy. You can try it afterwards. I'll do it afterwards. And then I want to find the average of what? Of grade. Grade is my numeric column. Right? Grades are the numbers, marks. Right? So let's only do this. And then do what? From grade center. Not here also. Before they start. And of course, since I have to find an average, I have to group them by student number. And if it says anything about ordering, no, it doesn't. So we can just stop here. And if you want to order by, you can always go order by 1. right? So we'll do this first and then we'll start doing the casting and so on. But that's simple logic. There is no having condition here, but there is a group by here. Right? So what is it saying? It's saying concatenate the first name and the last name, find the average of the grade from the table and group them by student number. Remember, grouping is very important. If you forget to group, you will see one name and one average value, because average gives you a single value. So it will show you the average of all the students of all the grades. That's all it does. So the group by is necessary. If it is not, try it without the group and see what will happen. Doesn't make sense at all. So let's run this now. So it is exactly doing what you told it to do. It has averaged your grade column. That's all you said. And you said, show me the first name and the last name put together. You'll say, which name does it choose? It just chooses the name from the first record. It doesn't care. You said, give me a name. It just chose it from the first row. But it only gives you one value because average is a single value. By grouping it, now you have more than one values. How many? Depends upon how many groups you have. So you will have as many average values as the number of groups. And then you say group them by student number. Again, student number is important because that's the unique part of every record. So instead of grouping by name, don't group them by name at all. Group them by student number. And then do an order. Let's try that again. And yep, there it is. So there were 1, 2, 3, 4, 5, 6, 7 students. Notice now the average. First notice the headings. It's kind of untidy. Look at the heading. It says concat. Of course it will say. You didn't give it any heading. The second one just says AVG in bracket grade. Not too bad, but of course not very neat too, right? So what will we do? Let's do it. Let's concatenate this and give it a name. You don't have to put else, but if you want to, I mean, it's fine. So you can go student name if you like. And the average grade, I'll kind of change it just because I have it now. I can say average mark here. I'll put a blank here instead of the underscore. Please change that in your question. And I'll call it average mark. Keep in mind, if it has a blank, you have to have it in quotes. If it doesn't have a blank, then you can put it without quotes. Doesn't matter any other character. Only other character that is allowed is the underscore. So, but if you have a blank, then you have to put it in quotes. Yes.
Why don't you have to use as here?
Because it's optional. You could and you could not. The word as itself is optional. Always, always. It's an optional word. Let me try to put it in one for you and not in the other. It is optional. The word as is optional. It's just more verbose. You understand what you're saying, but it is not required. Okay. So now let's see what happens. Let's try to run it again. Definitely neater. Student name is now saying student name, which is neater. And the average mark is saying average mark. It just comes on different lines because this is smaller. That's all. Right. But now the average mark, usually you don't see average marks with 4 or 5 places of 4. That's giving the 4 places of decimal. That's not how you usually do it. It's either one place, usually 1, not even 2, usually 1. So that's why I said cast it. Now cast it. All you have to do is this. Put a cast in front of it. We've learned the cast function before, except we've only used it in dates. And you want to cast this as a decimal. And I said I want one place after the decimal. Why did I go 4,1? Because average will always be less than 100. Right? For my marks at least. I have tiny ints. They're only, even if you think about 255, the mark can go only till 255. And averages, that means will be less than 255. So 4 places are enough before. So what does 4,1 say? 1 after decimal, 3 before decimal. So you're good. 999.9 is where you can go, and that's good enough for average mark because all your marks are tiny ints, unsigned tiny ints. So 0 to 255. So irrespective of how many you add, when you take an average, it will always be less than 255. Right? Now let's see how it looks. So what did I do? I casted it. So you've seen the cast function before. The cast function takes a value and converts it into another type. So you had taken text and converted it into date. I've taken an average, which was a float already, but I've said cast it as a decimal. So the type is decimal still, but 4,1, you could have said cast as float also if you like. It was not a big deal. Decimals are required more for monetary values, right? You can even use float and it will work. What else doesn't like something? Syntax error. Unexpected. Oh, maybe cast, maybe average returns a decimal or something, and then your cast, no, but that's coming down, right? Unexpected float. Wasn't it called float? What was it in MySQL? It was float. It was decimal, numeric, float, and something, right? It doesn't like it. Unexpected float. Decimal was fine, and I didn't even think of it till I was doing it. I thought, that's strange. It says unexpected. I'll have to look up why is it complaining of. So it doesn't like the 1, but that doesn't make sense to me. But no, it's not the 1. It doesn't like the float at all. That's really strange. I can't remember the 4th one. Do you remember the 4th type in MySQL, data type? Decimal, there it is, float and double. So that means something to do with the cast function then, right? We'll have to look up something to do with cast then, because float is a valid type. Let's see, why is it giving that? Cast functions and operators. Convert, cast a value as a certain type. The cast function takes an expression of any type and produces a result of the specified type similar to convert. For more, okay, convert then. Expression into type. So you can use a character setters also without. Doesn't say anything at all. Doesn't say something is not allowed, but when I try to use float here or even double, I think, let's see. Yep, both of them are creating problems. Is numeric okay? No, that means whenever you have to convert to a real number, you have to use decimal. That's the inference then. Right? So whenever you have to convert into a real number, you always have to use decimal. Float isn't working, double isn't working, even numeric isn't working. It's giving syntax error. Kind of strange, but anyway, you can't do much about it if it doesn't work. You have to follow what it does. Now try again. And that's your output. Right? So I've casted it with 1 place after decimal. 4,1 was more than enough. You have to think how much you need. And then the headings are what you have given there. I repeat again, if there is no blank, you needn't put it in quotes. And of course, if you had to order it, I think, order it. And since it was a calculated field, it's a calculated field. It's my calculation, right? I'm applying a function on it. I use 1 here. And 1 gives the position of the field in the select list. That's what 1 specifies. Okay. Or if you don't want to put 1, then you'll have to just put this whole thing. You can put this whole expression right here in order by. You can do that. It's a little untidy, but you could if you want. Yes. What isn't working?
For numeric arguments, various units function in double sum and everything to return a decimal.
Okay, so I think that's the it's not the problem, it's how it works. It says the average function, if the arguments, thank you, Ravinder, if the argument of the average function are integers, that means you're averaging integers, the result of average is a decimal value. That's what it is saying. But my thing is, even if it is a decimal value, taking a big, so it's complaining because you're taking a bigger value decimal and trying to convert it into a smaller one float. The opposite is allowed. Java will allow you, but it will give you a warning saying you're going from a higher type to a lower type. Decimal is the biggest and float is smaller than decimal. But MySQL is not allowing it. So it's casting usually is done from small to big, but you can do it vice versa also. You can in programming languages. MySQL is not allowing it. So average function returns a decimal if its arguments are integers or decimal, and it returns a double if its arguments are double or float. So average function is returning a decimal, and you can only cast a decimal to a, like you can go to a float, you can go to the lower one, you can go to an upper one, and there is nothing up more than decimal, like bigger than decimal. That's why it's not allowing me to do it. So there has to be a reason. Thank you, Ravinder. It's not from cast, it is from average. Average is returning a decimal value. Okay, so that takes care of another example by group by. So keep in mind, when I removed my group by, I only had a single value, and that's logical. Average will just average up a field. You're saying average up my grade. That's all you're saying. But now when I say group by, it's making groups and then finding the average in each group, right? So you should know all this too. Okay, so that takes care of grade center. Again, I'll put it back on Blackboard at the end of the class. Now you can start with your zip, the week 9 zip file. So I have that, all those files that I've given you, I also have them here, right? So I'm going to open them one by one. You can open them all together if you like. I'm going to start with not first normal form, change it into the first normal form. Then go to not second normal form, then change it into the second normal form. And then not third normal form and change it into third normal form. And at the end, I'll do the toys and boys. It's all boys and toys today. Do this, which is showing you or introducing you to joins. Okay. Okay, so let's start. So open up the first one. No hidden meanings, okay? Okay, so let's start. Now, what is normalization and what is this 1NF, 2NF, and 3NF? Let me introduce you to this first. There are more. There is a 4 and a 5NF also, and there is a BCNF, boys called normal form also, right? These are kind of in sequence. 1 is the smallest in its rules, 2 becomes higher, 3 becomes higher, 4 and 5, and then comes BCNF. So they're putting more rules on design principles. But these are design principles. The minimum requirement is that every table in your relational database must be in the first normal form. That is the minimum, not the best, the minimum requirement. Why have these rules been created? These are design principles, and you can say rules also. Why have they been created? Because if we follow these rules as we create our tables in our database, before we create them, of course, so the designing comes first and then comes implementation. Right? So if we follow these design principles when we are creating tables or designing tables before we implement them, then in the long run, the maintenance of the tables plus insertions, deletions, updations, all these anomalies or problems will not occur. But if you don't follow these principles, then you will have problems in all these operations. And that's all you do with a table. You insert data, you update data, you delete data. Selection is just selecting, right? Those are the changes you do to a table. So if it causes problems in any of these operations or causes anomalies or inconsistency or data integrity is harmed, then the whole purpose is lost. Because a database, the data in a table should always be perfect. In the sense, should always be correct. More than perfect, let me say correct. The correctness of the data integrity is an important principle of databases. And it is like, it's like garbage in, garbage out. If your data is wrong, how will your output be right? Same concept. If your data is incorrect in your tables, then of course your answers, your results, your output is incorrect. Okay, so that's why these principles are followed. So we'll go in 1, 2, and 3. 4 and 5 and BCNF are not in your course, and I'm not even going there. They become tougher and tougher, but I want to complete these 3 today for sure. And then once you see why do we require joins after you do normalizations, you will hardly ever work with a single table in a database because of these principles, one, and of course because you always work with like you just don't talk about a entity, you talk about entities in any environment. Even at Georgian College, teachers, students, part-time students, part-time teachers, like administration, there are so many entities that are kind of working together. Okay, so pick up the first. Oh, my name is wrong, of course, but anyway, you can correct that to your name anyway. So what does this first script do? It has shown you a table, and let's talk about what's wrong in the table, and then we will change it. So to create a database and a table therein, populate the table with data, check if the table is in first normal form. That's my first thing. So these files are called not 1NF. So what I'm going to do is so that when I put them on Blackboard, at least I know what I'm doing. I'm going to save them as, oh, let me first go through it and then do a save as. Okay, here is the definition. It says a table is said to be in the first normal form if two conditions have to be met. One, it has a primary key, which we have been kind of doing from week 2. We've always put a primary key because it kind of gives uniqueness to every record. And there is no repeating group of information in any column. Repeating group. The first example you did, your favorite sites itself was not in first normal form. Right? Why? Because we had discussed it then. I'll discuss it again. Because I wouldn't know what is the size of that data that I need. Plus, of course, I'll tell you more problems in it as soon as we look through the data. What I have done is, because I have no clue on which database server we will be working and what is on your machine. So when your assignments come to me, I want to follow this. And plus, this storage engine, InnoDB, follows the rules of foreign key, which you will learn today. And my ISAM does not, right? So please see that you start adding the set statement, which is setting your default storage engine to InnoDB in these scripts now from this point onwards, right? Even if it's your default, it won't complain. It's fine. If it is complaining, then don't put it. But before you give it to me, just put it because my system had my ISAM. I have no clue why. When I looked up my MySQL and looked at its myINI. Remember, we had talked about this initialization file, and I tried to find engine here to see what it was. It was coming up with default storage engine as MyISAM. I have no clue why. So, and it said, I kind of looked it over, 5.7, that's my version. So I have the latest version, but I don't know. So I kind of said, okay, what can you do? At least see, I have a 5.7.14. That was the latest 2 months back. So I said, who knows what's where? So the safe way, set your own environment, right? So by doing a set statement at the beginning of your script, you're setting it for everything. You can also only set it for a table. You can put it here also if you like. You can say engine is equal to whatever. It can be done per table also. So it gives you the flexibility. A table is following the ISAM, another table is following InnoDB, and there are 9 or 10 of storage engines. Of these 2 are common, so I remember them. But there are more. So you can do that if you want to do it for different tables. You can put an engine statement here and just kind of write it. It is called myISAM. And for this table, it will be myISAM. For all other tables, it will be InnoDB. Right? But I am keeping it at InnoDB because that storage engine enforces the rule of foreign keys, which we will learn today. And my ISAM does not. That's why. Okay. So please see that you now have this extra statement, set statement in your script before you give it to me. Because I'll be doing it. I have no clue what's happening with why do I have ISAM. Okay. So the 3 statements are clear. 19, 20, 21. Not a big thing at all. I've created a database by an odd name there, just so that it kind of says it's not in first normal form. Then I create a table therein, and the table is called TBL toys, and it has 3 fields. The toy ID, again, I need something to recognize a toy, and toy names may not be unique. So name of a toy is not a good field anyway. So I've created an auto increment integer field, which will become the primary key of my table. So I have a primary key. Then comes toy, which is just the name of the toy. I didn't know many, so I've kind of copied it. I don't even know what wiffle ball is. And then the colors in which that particular toy is available. Right? So here, let's see, is this table in the first normal form? There are 2 rules. 1, it has a primary key, which it has, right? But 2, is there any column which has repeating data? Or it is also said, if you read it on the web, if you go and kind of do a little more research, it says every column must be atomic in nature, cannot be broken down. Atom means cannot be broken down. But atomic definition kind of is taken in different ways in different tables. For example, if I wanted to keep the address, a bank usually will keep the address of a customer in parts. House number and street may be together, then the name of the city, then the name of the province, and then the name of the country. That's how they want to keep it, because if they're searching for all customers in Barrie, it's easy. All in Ontario, it's easy. They could take the whole field, but then they'll have to split it, right, using string functions, then pick up Barrie or Ontario after it and work. So they just put it on different fields because that's easy for them, because they do a lot of searches only on cities or provinces. So that's how they prefer to put it. So here now the address field is composite. For example, 1 Georgian Drive, our college address, 1 Georgian Drive, comma, Barrie, comma, Ontario, comma, Canada. So, but that's not atomic now. It has 4 parts to it. But on the other hand, for the same address, let's take something like pizza, right? So you order, they say, what's your address? Where do you want me to deliver it? You just go something like 1 Georgian Drive, room number A155. You just kind of say that is where it's delivered. Now, the database in their table is not concerned. One, they are not going to cater to the whole province. So they don't even want to keep the province. Two, they will be catering maybe within 3 or 5 kilometers of their area. So putting cities separately doesn't make a lot of sense. They're not concerned. All they're concerned is what's your address, right? So there also, if you say something like 1 Georgian Drive and then give a room number, if you want it to be delivered to a particular room number, they don't care. They say, for us, one address field is good enough in our database because we don't need to be atomic. It doesn't need to be atomic. So because atomic has different viewpoints in different tables, in one, it may be required, and in the other, it may not be required. Instead of saying every field must be atomic in nature, it says every field must be atomic in nature if needed, right? If needed comes with it. So is it needed? A bank would like address to go into different fields. Whereas does a pizza delivery company need it or a shop need it? No, it can go into one. So instead of saying that every field must be atomic in nature, where atomicness depends upon the application, they say that data must not be repeated in a group. So that way address is safe both ways, because you're not repeating 1, 1 Georgian Drive. 1 is the number, Georgian Drive is the street, and so on. So that definition, this definition has become more common than what it was when it began. It said every field must be atomic in nature, right? But keep that in mind if you read it. Now, what's wrong in this table? Do you see the third field which says colors? Even if I said color doesn't matter, but notice the values in that field. Some have 3, some have 2, and some may even have 1. So what is it saying? It is saying that this frisbee is available in green and yellow. The kite is available in red, blue, and green, and yo-yo is available in white and yellow, and wiffle ball in the 3 colors. Now here, this table is not in the first normal form. Let's look at what's the big deal. What would it cause? Why am I saying it should be in the first normal form? Primary key, of course, you know why. If you don't have a primary key, definitely will create problems. Why? Because the primary key uniquely identifies each record. So if I say nothing is unique, you may be repeating data. Like the same data may be repeated and you won't even notice it. So if I, for whatever reason, I remove this from here, I just go like this, right? And I say, oh, there is where I stop. Now I can do this. I can pick up this record and I can add it again. And it won't complain. When I run it, it won't complain. Why? Because nowhere have I said that the toy ID has to be unique. So you'll say, so what's the big deal? Repetition is the most big deal in data. When you start repeating the same data, and then what? Maybe here, you maybe miss a color. Here, inconsistency of data right at day 1. One is saying wiffle ball is available in white, yellow, and blue. And this other record with the same is saying, oh, it is only available in white and yellow. Mistakes like this can occur. Why? Because I didn't make a primary key. I didn't make a primary key. And this will run perfectly fine. It won't say anything. It won't complain. There it is. But now you have data integrity problems, right? The data is not, because it was repeated, it has problems of inconsistency right away. So you always should have a primary key. That's more obvious that, oh, you should have a primary key so that you don't create problems like this. Yeah, the repeating group now. Let's look at the repeating group. I have no clue what should be the size of my colors. I can guess. I can say, oh, maybe 40 if there are 3 colors. Maybe if there are available in 10 colors, 100 on an average 10. So I don't know. I mean, I'm guessing it could be, and some could only use 1 color, but varchar will take care of it. But at least, but I have no clue what should be the size. You'll say, I don't care. Let's make it maximum varchar 255. That's not a good principle anyway. You're not saying let it be the maximum, right? You'll say, so what do I do? Can I create 3 fields, color 1, color 2, color 3 in the same table? Then there is no repeating group. But then again, I don't know how many fields. Shall I create 5 fields? Shall I create 20 fields? I don't know. Let's look at, so that's one big problem. Second, suppose I wanted, so it's something to do with a person who's manufacturing these toys. He says, you know what? I want to now also start manufacturing toys in orange color for whatever reason. Okay. Now, if none of the toys yet have been in orange color, I can't keep that information somewhere that the orange color will now be a future color in my manufacturing. I can't keep that information anywhere. I can't add that information. Similarly, suppose I want to now, the person says, oh, I'll also start creating balls, small balls, right, for my small children. But I can't keep that information yet because maybe I haven't decided on the colors yet. But I've only decided, yes, a new toy will be manufactured by my company. So you can't add information easily in this table unless you have all the information. It should have a toy ID, a toy name, and it should have colors. So if I was able to design my tables in such a way that extra information can be added without having, like, it doesn't affect the records that are already present, but it's just extra information I want to add in my database. If I can do that. 2, there should be no repetition of data. And 3, I don't know what the size of the fields will be. I definitely have to think of a better design. And that's why we say every table must be in the first normal form. So let's change it into the first normal form. So the above table does have a primary key, but the colors field has repeating group of data. So this is not in the first normal form. Okay, now let's put it in the first normal form. Let's see if you can help me. So I'm going to save this as a different name, and that way when I put it on Blackboard, I don't have to struggle of what's where here. And I'll call it this. And just to be consistent, I'll start removing my knots out of my database name. You don't have to do it at all. Okay, now think about it. See what you can do. Help me out. So the solution is, I'll give you a hint. The solution is this table needs to be split up. You have to create more than one tables. And the join of all those tables will still give you all the information you have in this table, but you will have no problems inserting new data, thinking about sizes, nothing. There will be no problem at all. No problems of insertions, deletions, nothing at all. Right? Every color information will only occur once. You will not, you may repeat data here. I mean, for the, like, out of the blue, you could even say, oh, this color, and you can repeat your yellow, and there is no check on it. Why would you do that? Why are you repeating a color? But there is no check on it. All these problems or anomalies will go away when you start doing normalization. So I could have this, and there's nothing wrong in it. That error is not caught. If I run this script, that error is not caught. Though the yellow color is occurring twice. Why should it occur twice? It's not required to occur twice. But things like this, none will occur. There will be no anomalies like this. What do you think I can do? So the table needs to be split up. I'm sorry, that's too far. There's two corners here. So how do you split up? What do you think? So this one table will not work. I have a primary key, but I don't have the other part. Maybe I shouldn't have even put the primary key. What do I do? Think about it. Split it up. Split it up in such a way that all information is maintained, 1. And 2, when you join them together, it could be any number of tables. I'm just drawing them, right? But when you join them together, you have information. You have not lost any. Of course, you don't want to lose any information. Put your brains to it. Logically, not even talking about normalization or anything. Logically, what can you do? If you look at the fields, how can you break this table into more than one tables such that your information is not lost, no anomalies or problems remain, and every information is only at one place, and you don't create errors like silly errors like yellow color being put twice. I'll give you a hint, and then maybe you can start the next table. I'll create a table in which I'll put toy ID and toy, and you can call it anything. Doesn't matter. So this will be my one table. What will happen? The toy ID will come here. The name of the toy will follow here, whatever it is. Now, if I want to manufacture another toy, the company says, you know what, we'll start manufacturing another toy. They give it a ID and the name, right? This information is not yet, it's just new information, but I can put it in a place. I have a place to put it, whereas I couldn't have done it there. Now I have a place to put it. Every information is only occurring once. So that's one table that I can create. A table with toy and toy ID can be my first table. Now think of another table. What other information do you have in the table? Colors, right? So if I create a table in which I have a color ID and a color. So what do I again do? I give each color an ID, and then I put the colors red, yellow, blue, green, and whatever. Now, if I want to say, oh, I'll start manufacturing toys in orange color, that information can go in this table. And the information is only appearing once. No duplication of data anywhere. So the key of this will be toy ID. The key of this will be color. So I have two tables, but now comes the most important table, the connecting table. There will always be a table that connects the information. It's called the connecting table because I don't have this information that 5 is manufactured in white, yellow, and blue, and again yellow, which is a mistake, but that information. What should be my third connecting table? Anybody who would like to try? So toy ID's information has gone in one, color ID's information has gone in another, but this information hasn't come anywhere. So I definitely need a third table, which is a connecting table. What do you think can go in the connecting table? Can you think of what the fields of this connecting table will be? Toy name I hear, and color ID. So let's not go with toy name because toy names, though they're not repeated, but toy ID would be a better field, right? So toy ID and color ID. And the combination will be the primary key. You now are seeing a primary key which is composite. More than that, right? Now what will you do? 5 is occurring in color. I'm just kind of saying white maybe 1. 5 is occurring with yellow. 5 is occurring with blue, for example. Now, if by chance I repeat 5 and 1 again, it will cause a problem. Why? Because the combination is a primary key. I can't put duplicate information. That error has been taken care of. And then I'll go 6 comma whatever, 9 comma whatever, and so on. And it can repeat, 6 can repeat. Therefore, only toy ID cannot be the primary key. Only color ID cannot be the primary key because more than one toys are in the same color. But the combination of toy ID and color ID will be the primary key of that table. Plus, very important, any value that occurs under the toy ID field here has to draw its value from this table. You can't put a toy here 13 or 15 that doesn't occur here. Cannot. Because this is your major table from which you are inferring or referencing values. Similarly, you can't put a value of color ID here that is not present in your color table. So you're forming more rules, and the rules are correct. How can you put a table here? How can a toy occur in a color blue if that toy is not being manufactured by the company? So I'm putting more rules, and by putting more rules, I am ensuring that my data is always correct, right? So this relationship that the value of a field can only draw its value from another table in that particular field. The names is not important. Names could be different. But it is saying the values under toy ID have to come from the toys table, and the value in the color ID has to come from the colors table. This new restriction is called a foreign key. So like a primary key, which is a rule. What is the rule? It is unique and not null. What is the rule for foreign key? The value in a foreign key field must come from another table in which that particular field, whatever you call it, is a primary key usually. Right? Usually. That's what is a foreign key. So now my job will be to break up this table into 3 tables in such a way so that when I combine the information again, I have this table. So you can't lose information. But notice there are no problems now. You can add a new toy. You can add a new color. You are ensuring there is no duplication of colors or IDs. Nothing. Right? And that means if there is no duplication of data, data is always accurate. And if you want to insert information, you only do it at one place. If you want to delete information, you only do it at one place. And the job is done. Right? So that's our next step. So let's do this, because if I start doing it, it will take 10 or 15 minutes. Let's take a break here and then come back and see how to split this table into more than one tables. For us, 3 tables. Okay.
By the way, wiffle ball is
Yeah.
Usually they're white.
Huh? Always white.
They
Okay.
have usually,
Okay.
and they have holes.
Okay. And it's just like, oh, I know what you
It's
mean now.
kinda-
I've seen it.
kinda
It's like a hard plastic with holes in it, right?
It's a version of baseball.
Ah, for kids.
For kids, yeah. Usually you do it in the backyard.
Oh,
It's got like a
okay.
little
Yeah, I've
plastic
seen white.
pad.
You're right. I've seen a white ball with holes in it.
Usually it comes with like these little bases that you put in the backyard to make it like it's baseball.
Oh, okay.
But usually you throw it on your hand and they try to
Okay. I
It's
didn't know
supposed
what.
to be safer for kids.
Kids,
but
exactly,
then
because it's,
baseball,
yeah, because baseball is harder.
It's,
Okay.
it's a child version of baseball.
Okay, thank you. I asked yesterday. I didn't look up what it was. I could and I would have, but I didn't look
Yeah,
it up.
it looks like it's got a bunch of holes in it.
Holes in it. Yeah, yeah. I see, I've seen it.
That's a COMP2003. Going to be primary. Yes, it will. No, not only color, not only toy. But if I suppose that you have an just 12 with color, so you only put color. Yeah, color. Yeah, okay. But the advantage of creating this new table is that you can add information about the color that still does not exist, but they make the manufacturer may say, oh, that's the value item which I want to keep. So you're creating only so toys and yeah, color name will still work. It's not the best design, but yes, you could go with this and color name.
Okay, guys, let's get back to where we left off. So a question was just asked. Instead of going with toy ID and color ID, can you go with toy ID and color? Why even create the color table? The answer is yes, you could. There's nothing wrong in it as per se. But by creating a color table, you are kind of ensuring an extra entity that if color needs to be added, I can add it here. Yes, but you could, at least in this table, if it was not such a big deal, you could go with toy ID and color name. You could. Okay, it could be done. But what I'm trying to do is I'm trying to design something not only for the present, I'm trying to design something for extensibility. So if I needed to extend and the manufacturer said, oh, if I only want to keep some color information, where do I keep it? I don't have a toy yet in that color. Then I can always say you can put it in the color table, right? So I'm only not thinking of the data right now. I'm thinking of extensibility, and that's something you have to keep in mind when you create applications, because it's not what is now present. You always think of what may happen in future. Okay, so that's why. But yes, you could have. There's nothing wrong in it. Okay. Okay, so let's try now. Let's try to now create this design in this script. So what will I do? So definitely this table will have to change, right? And I'll have to create new tables. So let me create new tables first, and then we'll take care of this. So I'm going to kind of remove this comment because I'm now having more tables. So I'm going to create another table. This was table toys. So just kind of try to pick up, that way it's easy. And of course, show you new things. Or maybe just create it here and then insert data together. Okay, let's create more tables. So since I need 3 tables, I've done a copy and a paste 3 times, right? And though it's not necessary, I'll try to, it's easy if I have the data, then I don't have to keep splitting it. I don't know whether I got it. Oh, here it is. Then it's easy to split it. I won't have to put my brains to it. Okay, so we said our first table will be table toys. And I will need 2 fields in it. There. Oops, and let me remove this also. Oh, please see that if you had this, I didn't remove it from my original script. I'm removing it from here anyway. Right, so that's my first table. It's a table called table toys. It has a toy ID, which is the primary key of this table, and it has a toy. 1 table done. Okay, let's create the second table now. Again, remember the drop table command. I don't need it at all on my machine because like when I drop the database, the whole thing is gone. But students who are working on Dreamhost need to drop tables if you need to recreate them. So I'll kind of stick with that. I'm going to create the second table, which is called colors, right? I'll call it colors. Again, you can choose whatever name you like. Call it table colors. And in this, I'm going to keep a color ID and a color. Not colors, but a color. Doesn't matter what you call it. I mean, it doesn't say anything singular means it is plural or singular, but again, and make it varchar 10. And if you like, because you'll say, oh, this color ID must have a color, we'll also say this field is not null. Let's add not null to it. Why? In the first table, it was not important when I had the previous one, because maybe I don't write the colors at all. I just put an empty string. But here I'm saying this is an entry in the color table. This ID is this color. This ID is this color. So I'll make my color not null. Let's create a third table. So we'll create a third table. You can call it something like what I'm doing, which makes a little sense to me. I'm calling it toys and colors. Or you can even call it only toys, colors, whatever you like. That's my third table. Okay. And this one, as we decided, would have two fields, a toy ID. Of course, it won't be an auto increment field. It cannot be because it's drawing its value from the other table, and the color field, color ID field, which is again an int. And we'll say it is not null, can be null. Oh, wrong place. That's my third table. Right, that's my third table. But now I have to enforce that foreign key rule. Remember how I said that the toy ID in this table must draw. So are you with me? That's the first table. Table toys only has a toy ID and a toy. Everybody with me here? Right? So what I've done is I've created a table toys. Oops, I have it twice. My second table, I have chose to call it table colors. Again, it has an ID, which is a not null auto increment primary key. And notice the color is only 10. Before the field was colors and it was 40. Now I'm saying 10 is enough for color. You can go 15, doesn't matter. But roughly 10 or 15, whatever you like, right? And I've said this is an auto increment key and I've said there should be a color. So I've made them all not null. In the other, I didn't have it. Here I say, oh, it's a table. The color ID and color are logical values to put it. So I have it. That's my second table. The third table is the toys and colors table, which has these two fields. And what is the primary key of this table? You can put it in front if you like, but I'll kind of, it's when I have a composite key, I prefer to put it this way, then it's just more clear. You can put the primary key in front of each one of them. I think syntactically it could be okay. I'm not so sure. I just like to do it this way. So this is my third table. I have a toy ID, I have a color ID, and I have a primary key that is the composite key of both, right? And very important, notice these are just int keys. One, why int? Because they have to match the toy ID in the other table. Similarly for color ID, but these are not auto increment. You're not going to create them auto increment, but you're going to say that the value in this field has to come from the other table. And that's a new rule you're going to learn today. How do you impose that new rule? Yes. Yeah, I think so. Try it. I think you can. You put it in front of both the fields. No, it's not. That's what I'm saying. By syntax, it will be the combination. Right? I'm not sure about I do it this way, so I've never tried it. But if you put it in both, it won't complain. If it allows it. If it doesn't, if MySQL doesn't allow it, then of course it will complain. Okay. But Oracle, I think, allowed it. You could put it, or maybe MySQL, one of them sure does. And then the combination becomes the primary key. This is my preference, but it's not a rule. Okay. Now, how do I say that the value in this toy ID must come from the other table? This is how I say it. So you're going to create a rule. Rules in MySQL are called constraints. You're constraining it, right? You're saying this is a constraint on it. This is a rule on it. Constraints may not have names at all. Why I prefer to give it names, so that if you need to alter a constraint in the future, it has a name. And it's a good habit anyway. And the convention is, with the constraint, you mention the name of the table and the field on which you're placing the constraint. So you'll have to go table toys and colors underscore toy ID. You're kind of saying this is a constraint on this field in this table. Quite a big name, but it's a convention, right? Like it's a convention which you should follow. To me, they're not important at all because I won't be programming at all in this course. So I'm going to go easy. I'm going to say this is my first constraint, C1, constraint 1, and it is a foreign key constraint. But that's not the usual convention, okay? Just so that you know. And giving names is not important at all. You don't, I think you can go without it. I'll try. I'll comment it out. Okay, now what's the rule? The rule is that the toy ID is a foreign key. So you're saying my rule is that my toy ID is I just have to be particular about syntax. Yep, I'm going fine. So you're saying that toy ID is a foreign key. What is a foreign key? A foreign key is a field that references the value from another table. Right? Now, what is your other table? Your other table is table toys. Which field should it match? The ID. Perfect. But please keep in mind, and now put a comma. Here is where the definition of the constant finishes. So notice there are no commas here. This is one definition. The name of the constant and the constant itself, the rule. The rule is toy ID is a foreign key that is referencing the toy ID of the table toys.
So what's the significance of the C1_F table? What is that actually?
The name of your constant.
So you just chose that
because it was easy.
okay.
Right? Usually it's like this. You mention the table name. And again, just a convention. You mention the table name and then you mention the toy ID, the name of the field on which you are placing the constant. Like conventions of tables. You start with a table and then you give something toys or colors, which is useful. Same convention. Right? And why are names important? Because when you start to program and you want to work with a constant, it has to have a name. Like database has to have a name, table has to have a name. So for that, right? So if you want, you can, that's the convention, the name of the table and the field. I'll stick to mine. To me, they're really not important at, oops. Okay, references. How can you do an undo and undo? I don't know. Okay, so references from the table toys. Is there a way of undoing and undoing? Like I went one more Control Z than I should.
Control Y is redo.
Oh, redo? Thank you. I've never even thought of it, that I'm looking for a redo. And there your definition finishes. Now, please keep in mind that I don't have to place it right after toy ID. This rule can come anywhere before this closing bracket. I mean, it's a rule. I just placed it here because it was related to the toy ID. The name of this field doesn't have to match the name of the field from which it is referencing the value. Doesn't have to match because you're saying I'm going to reference it. You could call it anything you like. Why did I call it sim? Because I don't want to think of a new name and it makes sense. Right? Now, can you place a similar rule on color for me? Place a similar rule for color. And I'll show you how this rule is enforced. How is it enforced? So take a rule again, create a new rule, place it here just because it's related to color. Of course, definitely give it a different unique name because names should be unique. And color ID is a foreign key. And it is referencing the color ID from the table colors table. There you are. So now the third connecting table, also called the relationship table, has to define foreign keys. If you don't do it, helter-skelter. You could be adding toys in colors where toys are not available, colors are not available. Like you're just doing whatever you want. So by doing this, I'll show you how I will not be able to add a toy that does not exist in the toy table. And I cannot use a color that doesn't exist in the color table. So these are constants or rules on your table. And that's how you list them. Give it a name. I think it's optional. I can try. We'll know for sure. Yeah, doesn't complain anything syntactically. So names are optional, right? But the use of names, this is the name of your constant. The use of names, when you need them, you have them, right? If you want to work with those rules, and you will learn to work with your rules in your second course. I know that. Okay, so now my 3 tables are ready. Now what do I need to do? Insert data, right? I have to insert data. So let's start inserting data. So, sorry? Yep, sure. Always a good idea. Describe all your 3 tables. Did I have a describe before anywhere where I can copy and paste? No. Okay. Describe your 3 tables. Always a good idea. Again, please remember, a good idea for you. But when I say I don't want it, I don't want it. You know what I mean? Like then you give me 20 outputs and I'm searching for 4 outputs. I know what, when I ask an assignment or exam particularly, please only give me the output I ask for. Do whatever you like, comment them out afterwards. So you can show all your 3 tables, okay? You can describe all your 3 tables, of course. It's always a good idea. Definitely it's a good idea. That way, if you've altered something, if you've done something new, it's all there for you to see. The show command is not necessary at all. The show, what is it? Is it show description or is it show create table? Yeah, that's not necessary at all. The second one was colors. And the third one was table colors and toys. Remember, this is a very important aspect of joins, that you understand foreign keys. It's very important. And I won't repeat it, like it's now understood what foreign keys are. But today I'll talk about them many a times. So I don't want to show create now. Okay, now let's insert the data. What do I need to remove from the toys table? I don't need the colors. I just need the toy ID and the toy, right? But before I do that, I'm going to create my new table so that I don't forget my colors. Before I remove that, I'll copy the colors. Right, so what do you want to insert? Again, here I have done the toy ID because my toy IDs are not in sequence. They are 5, 6, 9, and 12. For whatever reason, that's what they wanted to be called. So that's okay. With colors, I don't want to insert color ID. I'm fine. I mean, that's what I said is the use of an auto increment. Don't bother about it. I won't insert it. So I have the colors are, I have a white, values. I have white. That's my, it's a text field. White. Then I have yellow. Just copy those colors before removing them. Then I have blue. Of course, you won't repeat a color. Makes no sense repeating a color. You're giving now, don't confuse that. Don't create problems in the good table. You have two IDs with the same color. We don't want to do that. Then we have green. I'm just picking up the colors from and only once. And then I have red. And if I wanted to add a new color, I could. It's not a big deal at all. It's just being added. Anything else that I've missed? White, yellow, blue, green, and red. White, yellow, blue, green, and red. Yep, we are good. All colors have been taken care of. Now you can remove these from your toys table. I just wanted them for reference. So notice, primary key in the first table, yes. No repeating groups. Yep, no repeating groups. The table is now in the first normal form. This table is in the first normal form. Does it have a primary key? Yes. My toy ID is my primary key. Does it have any repeating groups of data? No. Every field is atomic in nature. Cannot be or need not be broken down. That's all you have to remember when I say atomic. Cannot be or need not be broken down. My first table is ready. Now, if you wanted to add information about a new toy, all you have to do is add a new record. 13, stress ball. Right? That's all you have to do. I don't need a connection. I mean, I'm just going to, the manufacturer says, you know what, we are planning to create a new toy, to manufacture a new toy. Just add that information here, only at one place. Data is only occurring at one place. Let's look at the other table. Is the other table in the first normal form? Yes, it has a primary key color ID. I don't see any repeating groups of data. Primary color ID and color ID and color, single color. If I wanted to add a new color, no big deal at all. Just add it. Does it affect any other table? No. So there is no duplication of data. Data can be inserted very quickly. Can I update it quickly? Of course. I want to change yo-yo to yo-yo-ho, whatever. Just change it at one place. The red color is now called maroon. Change it at one place. So when there is no duplication of data, there are no problems anywhere. Neither in insertions, nor in deletions, and nor in updations. If I want to delete something, delete has a few effects. If you delete something from here, its child table is effective, but that's again more in terms of programming. But if I wanted to delete an information, I don't have to say, oh, where are you present? It's only present at one place. And that's the advantage. Information exactly at one place. No repetition or redundant data. Now let's create the third table. That's an important one. So now let's put into the third table, which was called TBL, toys and colors. These values. And now you have to be careful what values need to be put. Oh, I shouldn't have removed it yet. Anyway, okay, so here is the information. There is where I need it. 5, 1, the first wiffle ball in whatever white color. Okay, so just take it from me because I have it. That was the reason I got it. You could have kind of before removed it, have it, but anyway. And then 5, 3. Then comes 6, 4. You'll say, what an odd table. All it has is numbers. I can't make head or tail out of it. Of course, you can make head or tail out of it. When you display it on the screen, then you will make head or tail out of it. You won't display numbers 5, 6. You will display the corresponding colors. And that will make sense, right? Okay, 6, 4. Then you have 6, 2. Oh, so there is a 6, 2 also. No particular sequence, doesn't matter. And then 9, 5, 9, 3. I'm just going by what I had. So they are coming in a different sequence. And it really doesn't matter. 12, 1, 12, 2. There. That's your information. And now, of course, I would like to do a select from all my tables to show you that they exist, of course. So take your select clause. So this is table colors. And this is toy and colors. There it is. Save it, run it to see if we've made any mistake syntactically. Looks okay. No, of course it's not okay. Column count doesn't match value on count row. The first table itself, table toys. Oh, I know what I made. I forgot to remove the colors from here. I removed the colors from the data. I forgot to remove the colors from the field list. Can do that, of course. It says it doesn't match your count. You said I'll put 3 values. You only put 2. I had colors here which I forgot to remove. Commas and everything at the right place. Okay, let's try again. Okay, we are good now. So here are the 3 tables. The last table is not making any sense at all. They're just numbers. But if I combine it with this table and this table, then it will start making sense. So I can pick up 1. 5 is a wiffle ball. Color 1 is a white. So 5, 1 means wiffle ball is available in white. But you say, do I do that manually? Of course not. You don't do it manually. You will do it using joining in select statements. That will be our next step. So your database will never, very rarely, maybe 0.001% will have a single table. You will always have tables. When you have tables, you will always need to join them. And if you need to join them, you will have to learn how to join them. Okay, done. All 3 tables are in first normal form now. Toy ID, the primary key. Color ID, the primary key. Combination, the primary key. Please remember, why did I need the combination? Because alone, the toy ID will not work. I see duplicate values. Alone, color ID will not work because I see duplicate values. But there is no combination, no double. I can't put the information 5, 1 again. I can't. Try it. Try putting 5, 1 again. Something that I was able to do in my first table. Try putting it again and run it. What will happen? I'll get an error. It says duplicate entry for the primary key. You can do it. Make sense? Or you can't even do this. Try this. So if you want, you can make a note for yourself. I mean, I'm putting this in comments, but you can always keep them, right? So you can say these, and can you do this? Try doing this. Can you enter a record something like 10, 1? Can you do that? Yes or no? 10, 1. No, because 10 is not a valid toy. So try it again. So anything in comments cannot be done, okay? There it is. It says, how can you do it? And look at the error. It says a foreign key constraint is being violated. There is the rule. The rule says this value of toy ID, whatever you call it, doesn't matter. This value cannot exist because it is not present in the other table from which you're referencing it. If I don't place that rule, it won't do it. It will just allow you to add a 10, 1, but we don't want that. So don't remove that rule. We don't want that. It's incorrect not to have that rule. So this cannot happen. What about this? So I'm just putting some silly records, but then commenting them out. Hopefully it will make sense if you read it. Can I do something like, I don't have a 6 color. Can I do something like this? No. Why not? 9 is a valid toy, but 6 is not a valid color. Your colors are 1, 2, 3, 4, 5. You can do it. You'll have a problem again. And it will again say something about a foreign key constraint, C2FK this time. The first time it was C1FK. So now it's showing you the name, so you know which one. See, there's another use of a name. It's saying the first time it said C1FK was being violated. So I exactly know which one. I can go and say, oh, that's C1FK. And now it is saying C2FK is being violated. So you can't even do this. This can't be done, keep in mind. So I'm kind of putting them there, but of course I'm commenting them out. You can't do any of these. But the advantage, you can add a new toy without it being in the relationship table. You can add a new color without it being in the relationship table. And that's adding information for future, right? If required, of course. Done. My first normal form is done. So you should know how to convert a non-1F into a 1F. And it will always split into more than one tables. Could be 2, could be 3. Right? Okay, so done. Let's pick up the second one. Are we all okay with this? Let's pick up the second one. Not in second normal form. Pick up the one which says not in second normal form. There it is, not to NF. And open it. And I'll discuss what is now second normal form. So the minimum requirement of a table in a database is every table must be in the first normal form, which is also called normalization, roughly called normalization. Instead of 1NF, you can also call it 1NF, first normal form, or normalization. Minimum. That's the minimum rule. No table is created without that rules. Never. Okay, now let's go to the second one. The purpose here is to check. Again, please notice, I have a storage engine. I have my set commands, what I need them to be for my script. Don't rely on the server. Don't rely on my machine or your machine. It should be always given to me, right? Now, let's look at this table and see what's the problem in this table. I have a toy ID table from the previous one. That looks fine. It has toy ID, it has a toy, it has a primary key. It is definitely in the first normal form. Is it also in the second normal form? Let me tell you, if your key is not composite, it's a single field, then the table is automatically also in the second normal form. Because in the second normal form, the definition says is this. Let's look at the definition. A table is in the second normal form or 2NF if 1, it is in the first normal form. That has to be in the first normal form. You only come to 2 when it is already in the first. And every non-key attribute, that means any field that doesn't take part in the key, is completely dependent upon the whole primary key. That means your primary key is composite. If it is single, definitely it is completely on the whole primary key. But if it is composite, then comes the part of, oh, are you partially dependent upon it or are you wholly dependent upon it? So therefore I said your first table, so the first table is in first normal form, we know that, and it is also in the second normal form by default because I have one single field as the primary key. So where comes the question of partial dependence or full dependence? I mean, partial just means part of, but you can't, I mean, there is no part, there is only one field. Now let's look at the other table. So this is complete. This table is in the second normal form. It is, right? But now let's look at the second table. So the second table I've just called TBL toys other. It's telling you the inventory of it. It is saying that this toy with its foreign key, which is fine, is available in this store in this number, and there's the store address. Very common. You go to a toy shop, Toys R Us. You said, oh, I can't find that toy, whatever. Can you look up your records if it is available in New Market? I really need it. Okay, so he looks up, computer comes up, he says, this is the toy ID, this is the store ID. Is it available or not? Inventory? Oh yeah, there are 5 in stock. That's how it is working, right? So which toy in which store in which number? Very useful information for all stores. It's very common, not only in toys, everywhere it is common. Go to any store and you can get this information if it is available somewhere else. But also in this table, I have put a field called store address that is only dependent upon what? Is it dependent upon toys? No. Is it dependent upon inventory? No. It is only dependent upon store ID. Its relationship is only with store ID, nothing else. So now look at it. I have a toy ID, I have a store ID, and my primary key is composite. It's a collection, not a single one, a collection. Because toy ID and store ID both are required to find the inventory. Why is it the key? Because you can't say, I need to know toy 5. How much of toy 5? Where? In 1. Oh, I want to know what's the inventory in 1. Of what? Of that toy. So toy ID and store ID together are the primary key of this table. A single will not do because inventory depends upon both of them. But look at store address now. Store address only partially depends upon the key. It only depends upon the part of the key. It doesn't depend upon the combination. It only depends upon the store ID. Store ID 1, Berry. Store ID 2, Vaughan. Store ID 3, New Market. Here is a problem. You'll say, what's the problem? Let's look at the problems, right? One, this store ID, store address, store ID, store address will occur many times in your table depending upon how many toys does it carry. Toy ID 1 in store 1 address. Toy ID 2 in store 1 address. This definition, this information is being duplicated unnecessarily. Now, if it needs to be changed, for whatever reason, Toys R Us has moved from Bayfield to south of Berry. Now, this information needs to be changed, and it needs to be changed in God knows how many records. So wherever toy ID is 1, it needs to be changed. You'll say, that's okay, I'll give an update statement. How does it matter? The problem occurs about accessing the table concurrently. You are updating the record. One application is updating the records, and another application is retrieving information. And while it is retrieving, only 2 have been updated, the rest 4 have not been updated. It may get information from a wrong record. Duplication of data will always cause, without saying, will always cause problems in insert, update I should say more, problems in update and problems in delete, always. Delete, I want to delete a record, you'll say I'll give a delete wherever store ID is 1. Same problem. Records are being deleted from the table. At that point of time, some other application is accessing it. It accesses another record that says, oh, this store is still on Bayfield. Right? And it's logical. Duplicate data always causes problem, always. So we want to remove this duplicacy. And see, there is a duplicacy. For example, look at the duplicacy. The duplicacy is this toy 5 in 1, inventory is 34, 23 Maple for store ID 1 is occurring again here. 23 Maple occurring again here. Something else may also occur. The 17, Angel side, wherever it is occurring again. Anytime I want to change data or delete it, it's going to create problems. There are solutions. You can say, oh, I'll lock the table. The application will lock the table while it is doing updates and nobody else can access it. You're trying to find for solutions instead of starting with a good design. That won't work. Like, why would it? And suppose it's a table that has trillions of records. You can't lock it for all other customers. All other customers are sitting for you to change data just because you chose not to design the table well. So solutions are not always correct because they may work, but because you did not start with the right design, you have to now think of solutions. Why should you do that? If you start right, you don't need to think of solutions because there is nothing, there are no problems at all to think of as solutions. So what should I do now? Again, I have to break it up. My first table is okay, but my second table is not because there is partial dependency on the primary key. And that's exactly what second normal form says. A table is in the second normal form if it is in the first normal form and every non-key field. What is a non-key field? One that doesn't take part in the key. Inventory is non-field key. It's not in the primary key. Store address is not in the primary key. So non-key field, they're not part of the key. Is completely dependent. Completely, there is no partial dependency at all. So in your table, you see that the store address is dependent on part of the primary key, since it only depends upon store ID. It has nothing to do with toy ID. Does a store address have anything to do with toy ID? No. So this table is not in the second normal form. The first table is in the second normal form. But there is one simple rule. If your field is single, it's not composite, then by default it is in second normal form because partial dependency only comes into picture when there are parts. When there is only one field as the primary key, where comes the question of partial dependency? So the first table automatically by default, by having a single primary key, single field primary key, is in the second normal form. Now, what do you think the solution is? How will you break it up? Think. How will you break up this table so that I don't lose information? I remove redundancy and duplicacy. What should go in one table? What can I move into one table?
The address.
And?
The store ID.
Perfect. Store ID and store address go into one table because that's what address is dependent upon. There you won't have any duplicates, nothing. Why would you write a store address twice? And store ID will be the primary key. What about the second table? What do I leave there? Toy ID, store ID, and Inventory. Done. Job is done. So break it up, right? Break it up. So let's do this now. I'm doing a save as again. So let's say in second normal form. So don't forget your normal form definitions. And in the exam, they are sitting here if you need them. Okay. Okay. So let's again start. Okay. So in the first one also, I'll say now the tables are in first normal form. Okay. All tables are in first normal form. I have to change my comments because I'm now converting them into first normal form. And in this one, all tables now are in second normal form. Okay, so let's convert them now. Again, just for clarity and correctness also. This is because not doesn't make sense when it is there. I'm going to change that. The first table is okay. I don't have to do anything there. Oops, syntax error, guys. Underscore is missing. Though it wouldn't have caused a problem because drop table is something that I don't need anyway, but I had this for students on Dreamos. Definitely this will affect you. And an underscore was missing in the previous. So see, to me, it doesn't matter because I drop it, the database, and it works. If you run it, it should run. I mean, logically means syntactically. Oh, cannot add foreign key.
Using table underscore twice.
What am I using?
26 line.
26 line. What am I saying?
Table twice. There is no table twice.
26. What did I call it here? It is table twice.
Oh, you changed it?
Yeah, I changed it. It was here. It was different. What is it saying? Cannot add foreign key. It's somewhere else. Oh, you know what? I think I know what. Here, the underscore here is missing. At line number 37, the underscore is missing. You can pick up the line from here. You can see it's giving me a problem in the create table command. So you go there, right? Okay, so now let's run it again. Sorry, syntax errors twice. Okay, now we are good. Show tables at the end is just showing me all the tables, okay? That's what show tables does. So that's one, that's two, and I don't know what this is. Oh, describe the table. So syntactically it is fine. Guys, please double check before you start making changes. I'm so sorry. Syntax errors are two places. Table toys on line number where I dropped it. 19 didn't have an underscore. And line number 37, please, didn't have an underscore. Because I changed it afterwards. My mistake. Okay, so first table is okay. No problem in the first table. Create your second table now. So leave the table toys so that you can see it and create your second table. So let's drop the table. You can call it store information if you want. Because we are keeping store information in it. I'm going to remove the toys other. Wasn't a good name anyway, but anyway, I mean, it was just, I knew it was just there for a while. So drop that table by that name. Create it again. And we've all agreed that the structure of this table will have the store ID. Oof, the store ID. So you can pick up the store ID from here. Oh, because it is, yep, okay, I'll have to add and pick up the store address. These are the two fields. Right now, again, in store ID, you can make it an auto increment, and there is 1, 2, 3, 4. Okay, but I mean, it depends on you. It's not a big deal. You don't have to make it auto increment, but fields like these that don't make any sense, you thinking of a value, are usually auto increment. There. That's your second table, your store information table. Make sense? So store ID and store address. I took the store address straight from the others table. It was varchar 30 not null. And store ID, I had to create it as an auto increment primary key. Table 2 is ready. Now table 3, right? That table 3 is right here. Oh, something else. No, not here. No, not here. Now my table 3. What would we like to call it? You can call it toys inventory if you like. It's telling you about inventory, right? Or you can just call it table inventory if you like. Let's call that table inventory, right? It has a toy ID, it has a store ID, and it has a primary, but you will have to add a constraint. What's the constraint? Toy ID is coming from the toy ID table. That's already there. Store ID will come from which table? The other one. I'm calling it C2FK. It's on the store ID. And it's drawing its value from, what did we call it? Store information. Oops, no. Store information. There it is, store information. And you'll have to move it before it because it's referencing it. You have to just move it at the right place. Okay, so we'll start again, okay? Bear with me, I'll show it to you. I'll show you the three tables. Okay, so table number 1 had no change. That was your table number 1. TBL toys has no change at all. Okay, your second table is your store ID table. That's your second table. Matches with mine? That's your second table, the store information table. We all agreed on it because it makes sense. In this, I have created store ID as an auto increment primary key. Third table, semicolon. Third table. Give me 1 minute. Let me just copy it and bring it. Oops. I'll do my insertions afterwards. Just creations first. That's your third table. Let me give you more space so that you can see more. That's my third table. And we called it table inventory. I called it table inventory. The table inventory is saying which toy in which store in what quantity. Which toy in which store in what, in how much, right? So of course, the toy ID value has to come from the table toys. The store ID has to come from the store information table. So you should be creating it before. Don't create it afterwards. You have to create it before. SQL goes in sequence. Okay. SQL statements are executed in sequence. So create the table toys first, then create the store information, and then create this table because it is referring to those tables. It's like procedural programming, one by one. Okay. This is my third table. So just so that you can see it, I'll kind of just for here, there. That's my third table.
Store information should be store ID.
Store information which should be store ID. Definitely. Thank you, Manda. You are picking up the store ID from the store information, not the toy ID, of course. And it would have given an error, of course. Make sense? So now I have three tables. I have to put data into it. You can describe them and you can, of course, then put data into it. So the three tables are ready. All three tables are in the second normal form. The first two definitely are. They have a single key. This one has a composite key. And notice the only non-key attribute is inventory, and it is dependent upon, it's not dependent upon part of the key. So this table is in second normal form. Now distribute your data, please. Into the table toys is okay. Into the store information, where did that go? There it is. This definition is just sitting in out of the blue from nowhere. I'll put this definition up at the top so that you have it always. So that's my first table, my second table, my third table, and then you can describe all three tables if you like. They're called table store information. That's your second table. Your first table is toys. And your third table is, table inventory. So describe all your three tables. In any order, doesn't matter, but anyway. Here are your three tables. There it is. Okay, so all three tables described. Now start inserting data, please. Table toys doesn't need any change because it was right in its first go. Okay, let's look at the other tables now. Now in the other tables, I have extra information, of course. So let me try to insert into the second table now. I have no time to put comments, guys, but that doesn't mean you won't put them when asked. Okay. Okay, what did table inventory have? The table inventory had a store ID and a store address. And they are actually here, 1, 2, 3, and 4. So if you don't want to put the store ID, just copy the addresses. Okay. So let's put the store address. But be careful that you put it in the correct order. Okay, so the 1 is 23 maple. Put your 23 maple here. That's your 1. Oops, that's 1. 2 is 1902 amber line. I'm assuming LN is line. That's address number 2. Address number 3 is 100 East North Street. Please pick them up properly. Otherwise, put both values if you can't remember. Third value. 4. 4 is 17 Angel Side. It's not, I don't know. That's how you say it. It sounds like an A. And there. And there. And there. The sequence is important, guys. 1, 2, 3, 4 is important. The word values is missing. That's my table number 2. Store ID 1 is 23 maple. Store ID 2 is 1902 amber line. Store number 3 is 100 East North Street. And 4 is 17 Angel Side. All information only once. Right? So my second table is ready. Now the third table was called, it was a big name, so I'm going to copy it. Table store information. Oops. Third table now. It will take more time than anything else. Oh, okay. What else can you do? You have to do what you have to do. That's why, of course, this is not what you would be doing as a professional, but since we didn't start right, we have to do it this way. So after this week, we will always create our tables in the third normal form. We've learned our lesson, so we won't do it again. Of course, the same thing will hold. You cannot add a record for a non-existing toy ID or a store ID. You can't do either. So both is not possible. A non-existing toy ID is not possible. A non-existing store ID is not possible. That's not so important right now. We've already learned our lesson, but anyway. Okay, so now remove. What do I need? Toy ID, store ID, inventory. Remove the addresses in every record. 1 gone. Store ID, toy ID, inventory. Leave 3 fields and remove the address. I've already copied it, okay? And you have to. Foreign key. Don't forget your rule of foreign key. You can't add anything that does not exist logically. So remove the address from each record and change the name of the table. Oh, Control F would have been better. Anyway, it's done now. There it is. And remove it from here. No store address. No store address. So 3 tables, all 3 in second normal form. And we'll do one more. The third normal form. There it is. Tables are ready. And then, of course, you can do your select clauses. That's my second table. And there's a third table. That's my third table. All 3 tables are ready. So we've split it. Anytime we want to join them, we have to learn how to join them, but we can, and I'll get my information back. You want to add information about a new store being opened, you can add it in the store information table. Right? Nothing stops you. You want to add information about a new toy, add it in the toys table. Of course, when you want to put a combination, this toy in this store, in this inventory, you have to use the third table. Okay, now when you run it, if syntactically unknown store address, what did I do? Where? Insert into table inventory. What was it spelling? Did we call it something else? Store address, ADDRESS, store address. Oh, no, the table name is wrong. Oops. Okay. It was called table store information. That's why. Sorry about that. It was called store information. The third was called inventory. Ah, I have it at, oh, don't tell me. Oh. This is inventory. So sorry, guys. I'm really sorry if you were copying me blindly. That's why I hate writing single insert statements. There. I messed up the name of my tables. The last table is the inventory table and the second table is the store information. Run it again. Okay, good. Now we are done. Inventory, of course, only numbers makes no sense at all, but when combined with the first two tables will make complete sense. You pick up the number from here, pick up the number from here, and show the result. Numbers mean nothing. You always show the toy name, you always show the store address, and then you show the inventory. And that's what I said we would learn. Right? Done. Now this table is in the second normal form. Every table is in the first normal form, and every table is also in the second normal form. Let's go to third now. Okay, open up not 3NF. Let's look at the definition first. So now a table is said to be in third normal form if it is in the second normal form. That means automatically in the first and second. And it has a condition. We'll talk about the condition after I show you where the problem is. So I have a database. I have a table books. This one only has one table. I couldn't find any other example. But anyway, here is the need is to show you what's wrong with it. Now this is a table about books where I'm keeping the name of the author. I'm keeping the name, the title of the book. Who is the publisher? The names are not good at all. It should be publisher ID, never go small. And then what is the city in which the publisher office resides? So for example, Introduction to Java by Detail and Detail, Wheelie Productions, and New York, I think they're in New York. That's what it is. Now, what is the primary key of this table? Now, if I want to find out, there are many books that an author writes, of course, and there are many same titles. Intro to Java, there could be many books. So alone, they cannot work as a primary key. Publisher ID cannot work as a primary key at all because the same publisher publishes many books. And the publisher city depends upon the publisher ID. So definitely city will not work because the same publisher may be residing in the same city. So those are out. But so two options. One, I can create an ISBN for the books, which is what it should be. Every book has a unique ISBN. So I can create maybe an auto increment key or an ISBN. But this table, I can use title and author together. The same author will never write the same title book again. It could, but it could be edition 1, edition 2, and so on. So the title always has a different edition. And so that combination is always unique. So the same author can write different books. The titles will be different, but the title will never be same. Similarly, the one title, Intro to Java, can be written by different authors, but the combination will never be same. So combined key of author and title are the primary key of this table. I chose to do it because I want to show you something in this table which is not correct. I could have chosen ISBN. I did not. I could have created an auto increment ID. I did not. I want to stick with this primary key, whether you like it or not. Okay. Now let's look at the problems. What are the, if any, if there is a problem? So that's your key, keep in mind. So now the rule says, let's look at publisher ID. Publisher ID is completely dependent upon author and title. Because if I say Intro to C++ by Detail and Detail, it's published by White. You know what I mean? You cannot have a different publisher ID. It's completely dependent. So that's how you find IDs. What about publisher city? What is it dependent upon? Is it dependent upon the key at all? No, it's not even dependent upon part of the key. It's not. It has nothing to do with either the author of the book or the title of the book. But what does it depend upon? pub ID, the publisher ID. So here you see an indirect relationship. This is called non-transitive relationship. So publisher city depends upon publisher ID. Publisher ID depends upon the key. So you see an indirect relationship with the key. You see a relationship, but that it's indirect. It's no direct relationship at all. It's not dependent upon the key at all. So this table is not in the third normal form. Actually, it is not even in the second normal form because it doesn't depend upon the key at all. But the definition of third normal form says a table is in the third normal form if 1, it is in the second normal form, and 2, every non-key attribute is directly dependent upon the key. There is no indirect or non-transitive relationship. And we see it here. City on the ID and then ID on the key. So this is indirect, right? So A depends upon B, B depends upon C. You imply that A depends on C. In mathematics, we've learned it, but it won't work here, right? So here we have to take care of it. So a table is in the third normal form if it is in the second normal form and every non-key field, something that is not taking part in the PK, the primary key, is non-transitively, also called directly dependent upon the primary key. That's the definition of third normal form. Now we have to break it up. You'll say, now what's the problem? Same, duplicate data. Publisher ID, publisher city will occur as many number of times as that particular publisher has published books. If I want to update it, duplicate data. If I have to delete it, duplicate data. All these problems are ensuring that there are no duplicate records in your table, because duplication of data always causes problems in data integrity or data accuracy, right? And if data is not accurate, garbage in, garbage out. Okay. So what do I do? How do I split this table? What should I do? How many tables should I create? 2 or 3? I don't know. But what should go in one table and what should in the other? So author, title, and publisher ID can go in one table. I see direct dependency and there is no partial dependency. And what goes in the other table? What goes in the other table?
City.
Publisher ID and city. What else? There is nothing else, right? Again, you can add information about a new publisher. I decide to become a publisher. I am in Berry. This information can only go in my table, in the publisher table. I don't have to, publish a book before I become known. You know what I mean? Like I can still open my office without publishing a book. So that information can go there. There is no duplicate data. Information only occurs at one place. Updates, deletes, everything is easy. So now let's split up this table, right? So I'll save this. Hopefully I haven't made any syntax errors here. No, I'm going to now save it and change it. So let's save it in the third NF and let's start doing it. Okay, so all tables now will be in, after I'm done, will be in third normal form. So I chose a simpler example for the third normal form where you could see directly. But I mean, I didn't stick with the other one. And it was easier, of course. So we won't do 4 or 5. So please don't forget your set statements. And then I'll change this name. By the end of the semester, I have so many databases on my machine. And if I forget to remove them, which I usually do, then they just go on, pile on to the next. Okay, that's my first table. Drop the table if it exists. Table books is a good enough name. What I'm going to remove from here is the ID. And I'll take this definition and move it up because where it is. Okay, so let's create the second table before I kind of go it. Let's call it table publishers. So you can call it publishers because it is showing you the publisher information. Remember, names of tables should be good too. And then table publishers. And the 2 fields that we want. We want a publisher ID and a publisher city. But we have to be careful. This will be our primary key in this table. Oh, this table will have to go up, guys, because of drawing its value. Anyway, we will in a minute. And this will be an auto increment. I don't need not null now. It will be an auto increment primary key. And again, you can You cannot make it auto increment if you don't want to. There's no rule at all to make it auto increment, guys. There's no rule at all. But sometimes with numbers like this, student ID makes sense, employee ID makes sense, customer ID in a bank makes sense, but a publisher ID necessarily may not make sense. But it's not necessary that it be an auto increment key. You can make it whatever you like, right? So I'm just doing it because it's 1, 2, 3, 4. That's all, and it's a primary key. That's one table, okay? And now this comma is not required. And now remove the publisher city from the other table. Remove it. I have two tables. Yes. It wasn't, because it said every non-key attribute must be fully dependent upon the key. It wasn't even. Yeah, it wasn't even in the second normal form. You're right. So where comes the question of third? It was not in second and not in third also. I mean, that's why I said this was just a simple example. First, second, and then kind of into third also now. It will automatically go to third now. It will. But I was trying to show a non-transitive relation instead of a partial dependency. That's what I was trying to show you. See, in a way, you could say it was not in second normal form, or you could say, oh, it was in second normal form because I didn't find any key that was partially dependent. You see what I mean? You could take it either way, because there was no non-key field which was partially dependent. It was not dependent at all, but it was not even partially dependent. So, but you are right, it was not in second normal form. I would take it not to be in the second normal form. But as I said, this was the easiest example I could find. Okay, so now that's one table, table books, and that's another table. I just want to see, I think, I'm almost positive that it will create problems. Oh, not yet. Okay, what do you have to do with the publisher ID here? You have to make publisher ID a foreign key. Publisher ID can only draw its value from the other table. Okay, so make it a foreign key. Create a constraint. So don't forget, as soon as you start splitting tables, oops, constraint. As soon as you start splitting tables, take care that foreign keys constants come into action. Okay, so you can call it whatever. I'm calling it S1FK for foreign key. Oops, foreign key. Yeah, foreign key. What is a foreign key? The publisher ID is a foreign key. Why? Because it is referencing. Because it is references. It is referencing from the other table TBL publishers. It is referencing, what did we call it? Pub ID there also. We called it pub ID. That's why if you keep same names, then it's kind of easy, and then put a comma. There. So please don't forget to add this. As soon as you split the table and publisher ID becomes the primary key of another table, this value must refer to that table. I'm just trying to see. I'm almost positive it should complain because my table comes afterwards, but I'm just going to see and run if MySQL complains. Logically, SQL statements are executed in sequence. Yep, see, there it is. Cannot add foreign key constraint. Why? Because the table is not defined. So please see that physically you place the table publishers before the table books. Why? Because table publishers is being referenced in the other table. Physically place it. You must physically place this table. You must create this table before you create the second table because it is referencing to it. And now if you run it, it should work. Yep, it works. So yeah, I was right. I just wanted to double check. It has to be placed in the correct order. And order means if you're referring to something, it should be available. Right? So since the second table, notice there is a foreign key in the second table referencing the table publishers. That table publishers must already be created. So the tables are ready now. Now what do we have to do? Put data into it. Of course. So go and insert data. So insert before you can again take your describe statements and put them here and here and call it publishers. There. And now and of course the select will also come. Okay, break up the data, please. And insertion doesn't matter. Sequence of insertion doesn't matter at all. The sequence of creation matters. It should be created before you use a field in it, right? So that doesn't matter. So insert into this now. Insert. Insert into table publishers. Values. Okay, we have a 1, we have a 3, and we have a 5. We don't have a 2 and a 4. Notice we have a 1, we have a 3, and we have a 5. So I'll have to go pub ID and pub city because they're not in sequence. And therefore I said that you can, it may not necessarily be auto increment. Okay, so what do we have to insert? A 1 and something, and that something is New York. That's New York. 1 is a publisher ID. Was it text? Wasn't it text? Oh no, it was an int. Sorry, it was an int. It was an auto increment field. That was a stupid remark. 2 is not there. 3 is a San Francisco, and 5 is Boston. There, and 5 is Boston. Remember, you can't use text data without quotes because then it assumes that is the name of a field or something. There it is. Both tables are ready. And now remove it from here. Oh, there is a 2. Sorry, there is a 2. I see a 2 with the New York also. They can be same. It's no big deal. 2 cities can be same, but the IDs cannot be same. Okay, so now remove the cities from your table. So 1 is New York, 2 is also New York, and there is nothing wrong in it. There is no problem at all. IDs are different. And there it is. So table books has author, book name, and publisher ID. And publisher's table has publisher ID and book name. Sorry, publisher city. There it is. Both tables are ready. And again, if you want to draw information, then you have to combine the 2 tables. So easy being green, so tough to see it from this side. So easy being green by John Jerry was published in New York. So you'll have to combine those tables to get your information. But that's not a big deal at all. As I said, we are looking for good design, not for easy solutions, right? So if they're designed well, then in the long run, you'll never have problems with maintaining it, adding data, updating data, or deleting it. These are principles. If they are followed, somebody has made those principles. Taken quite a bit of time to do it. But they don't end here. You have a 4NF, you have a 5NF, and then you have a BCNF, Boyce Codd normal form. I don't know why they called it that. Didn't go to 6, but gave the name whoever made that rule, right? So it's called Boyce Codd normal form. But in your syllabus, you stick to 3. So I'll stick to 3. The database design is itself a whole course. It can be a full-fledged course. You can be a database designer instead of a developer. It's a full-fledged course. And databases are very interesting. So if you think that this is your field of expertise and you don't like Java a lot, that's okay. Choose this field. What's wrong in it, right? If you think that web programming is something you enjoy more than Java, choose web field. That's the advantage of COPA Copper course. You see everything. And you also see mainframes, right? Mainframes is another field which is very interesting. Really, like it's very interesting. If I had not been teaching, I would be either in database or mainframe. I used to like them. Those are my favorite ones. That's another interesting field that is never going to die, right? And it is advancing, like it's still old kind of stuff, but it is advancing, but they're interesting. So not knowing Java or not understanding Java is not something, it's just not that you can do it. It's just not your cup of tea, right? Take it at that way. Can everybody be everything? No, I can do web programming. I don't like it. I can do application programming because I've never done it. So I enjoy this more. So take take what you like and try to go forward in that field. So students, a few students are stressing because of Java. That's okay. You know what? It's not the end of the world. Choose something that you like. And we have so many options, like go into web if you like. If you don't like computer technician, go into web. But if you still want to stick, then say, okay, Java will not be my plus point, but I'll do the others. Then you have a flavor of everything. Right? Okay, so done. We are done with this. We are now in third normal form. Now comes the big question. Splitting of tables was okay. Now from this point onwards, we'll always create tables in the third normal form so that we don't have problems. But now how do we combine them back? If I want data, for example, in this one itself, what do? I have to join tables. I can only work with joining tables, working with more than one tables together. And that's your next part. So I've only shown you how to split. And now all tables are in their proper form, in first, second, and third normal forms. Your next job is now to split. We don't have much time, but I'll just open it up and then we'll discuss it, kind of discuss it, and then we'll take it from there, okay? So this was your last script that was given to you. Right? So this will help you. We'll start with all options, but then I'll stick to the easiest option. When I mean all options, I mean syntax options, right? When to use the word join, when to use natural join, when to use so on. I mean, there are options, or just use comma and you're okay. Why even write the word join? But of course, when you begin, you will be learning the syntax completely, and then you will stick to the easiest format. Like, is the word as needed? No, don't write it. Describe just can be written as DESC. You know what I mean? So I'll give you all formats. It will be a little boring for the first 15 minutes or so. And then once you have it in your head, we'll start doing the easy way, using commas for joins. Okay. So if you open this up now, the last one, I'll just take you. I won't take more time today because I know I can't complete it. I won't. Every time I take 5 extra minutes. So what I'm doing here is I've already given you a database which already has tables, and it says all tables are in third normal form. They're definitely all in third normal form now. So we are past that stage. But you've understood why normalization is required. And the rule is every table must be at least in the first normal form. The more, the better. If you go up the steps, the better, right? So your aim should be BC and F. But anyway, and now my aim is to retrieve information because numbers don't make sense to me. Store ID, toy ID is making no sense to me. But if I combine it with toys and with colors and give you an answer, then it makes sense. Wiffle ball is available in white color. Yo-yo is available in green color. Then it starts making sense. But if I say 5,1, nobody can make sense out of it. If you see just that table, select star, you'll say, what is it? What's 5,1 mean? What's 5,3 means? Nothing. They won't mean anything to a common man. So we will learn how to join tables. Okay. So this one is simple. I've dropped the database. I've created one. And just so that you don't forget, because you tend to forget if I don't do it for a while, I have not used the database, but I've used the dot notation. So when you don't use it, then you have to just qualify your table name everywhere. And it can be done. And this will allow you to actually, the use of this is it allows you to refer to different tables from different databases, because you have to use a database before you use a table. So instead of saying use DB1 table, use DB2, then you can use a table. It's just, you can just qualify them. And the qualification is simple. Name of the database dot name of the table. So there is a toys table here. I've added more data to it. So instead of just 4, now I have hula hoop, glider, toy soldier, so on. I have more toys. Then I have a boys table, which is saying this boy is called David, Bobby, Beaver, Richie, Johnny, and Billy. These are names of boys. And then comes a third table, which says, which is Greek. 1,3 is trying to say Bobby has a harmonica. You know, this is what it is saying. So it is saying that the third table has a boy ID, which is drawing its value from this table. The boy IDs come from this table, right? And it has a toy ID, and the toy ID is drawing its value from this table. So the combination is, for example, 1,3 means Davy has toy soldiers, right? So information split. Now, if you notice this one, why int 11? I've never used it because in the create table command, it will always int 11, it's default, but that's not the size. Don't confuse it with size. And you know what? I must remove it. I have used it from a create command and pasted it here. Int 11 simply means when it will be printed, it will have 11 digits by default. It has nothing to do with storage at all. Absolutely nothing. Even if you see tiny int 3, I've seen you using it in your first assignment because it was in the manual. You're thinking, oh, tiny int 3 means I need 3 bits for it. No connection at all in storage, only in printing. Okay, why tiny int is 3 in size, 255. So you are saying tiny int 3, print everything in 3. Even if it is only 2, give it space of 3. So don't confuse that 11 anywhere, and I'll remove it. So you see, this is not, if you notice, it's not my way of writing it. I don't usually write my ints in small. My varchars are always in cap. Copy paste, okay, cheating. But that's just being lazy. So now the aim is, how will you tell me, how will you interpret this table for me? What does 1, 3 mean? I have no clue. I mean, we will once we know. And then there is a fourth table here, which has a toy ID and a color, which is saying which toy, oh, that student has left. This is an example of where instead of using color IDs, I've used the color 5 white, 5 yellow, 5 blue. And that was exactly the question that was asked of me. Do we need to create the third table? He said, why are you creating this table? Can't we simply say 5 white, 5 yellow, and 5 blue and so on? I said, yeah, that's perfectly fine. But in the long run, it would be nice to have this table where you can add more colors without having a toy in that color. So definitely this is better, but it is not wrong. It wasn't wrong. So it's left now, but here is an example where I have said, okay, these toys are available in this color. So 5 white, 5 yellow, 5 blue, 6 green, and so on are simply not using an ID, but using a color. If I had done it on my own, or maybe I will before I start doing it next week, maybe you know what, I'll change this table. I'll create a color table in which I'll put these colors, and then here instead of 5 white, 5 yellow, I'll use them. 5 1, 5 2, 5 3. I would. I mean, I will think of extensibility, right? And our aim now will be to combine these tables in such a way, I'm hoping it will run. So I'll give you this code again. I mean, I'll change those color IDs just because I think it's better way. And then we will learn how to do Cartesian products, inner joins, natural joins, outer joins, and so on. So this here is where it becomes a little complicated from what you've been doing till now, right? So don't be afraid of it. We'll devote it time. We'll give it 4 weeks. The rest is all on this, joins and subqueries. But do it seriously. If you don't pay attention, you will not get it, right? So don't miss classes and pay attention. It will help. Okay, so I'll see you next week and we'll start working on joins.